Hello everybody, welcome to your next flip lesson, which is going to cover inequalities. We have a couple learning targets here we're going to cover. One of the learning targets is that you, the student, will decode basic symbols and terms used for inequalities. And the second learning target will be that you will graph and interpret solutions to inequality problems. So basically this is going to be an intro to inequalities. I'm going to show you the basics of inequalities, what inequalities mean, how to write an inequality problem, how to graph it. So that's what we're going to cover today. Okay, let's first start off with the signs here, and this should be no surprise to a lot of you what these signs are. At least 2/3 of these signs should be no sweat for you. We've got, of course, we've got equal and unequal, and then in the middle we have the greater than and less than sign. And I don't know if I've talked about this before, but one thing that kind of helps people with inequalities is, just having the big N pointing at the big number, small n pointing at the small number. That's a good way to remember it, because I think sometimes we just end up switching our signs and getting it mixed up. And then this might be new to you right here, these two, which is greater than or equal to or less than or equal to. So if there's a line underneath it, like this, or it's written like this, it means or equal to. So less than or equal to or greater than or equal. Another thing that you're going to be required to know is phrases, the basic inequality phrases. Just like we've been talking about with algebraic expressions, there are words that go along with less than, greater than, other than the obvious less than, greater than. A is more than B is going to be written like this. A is at least B, and that could be a tricky word, and we're going to get more into that in a little bit, but A is at least B. And that doesn't seem to make sense, but at least means greater than or equal to. I mean, it's just, think of a real life example of what at least means. For instance, you could say, well, I had at least 5 donuts morning. You said I had at least 5. What does that mean? Does it mean you had 1? Does it mean you had 2? Probably not. At least means you had 5, or maybe you had 6, maybe you had 7. So at least means greater than or equal to. If you had at least 5 donuts, you had 5. You had 6, you had 7, you had 8, maybe you had 20, who knows? Hopefully not that many, but that's what that means. At least means greater than or equal to. And same goes with this sign down here. That sign is less than or equal to. And a lot of times that's going to be phrased as at most, or no greater than, or no more than. And let's go back to our donut example. If you had no more than 5 donuts, well, that means you had 1 donut, you had 2 donuts maybe, you had 3 donuts, you had 4, or maybe you had 5. But no more means that's it. You can only have 5, or maybe just 1, or maybe none. Maybe you had no donuts whatsoever. That sign right there, less than or equal to, means no more than. A lot of times when you get into these inequalities, and especially the phrases that go along with these inequalities, it seems totally backwards. And I hate to say, think of it backwards, but that's kind of how I always do it. I just think, okay, at least means greater than or equal to. At most means less than or equal to. Moving right along. Here's a real life example of an inequality problem right here. Speed limits, for instance. Speed limit, a 75 mile an hour speed limit means that you can go no faster than 75 miles per hour, right? Nobody has parents that speed. I hope you don't. Nobody speeds. You see a speed limit sign. The speed limit 75 miles per hour, which isn't very common around the Chicago area because we live in an urban area. But go out into the country and you'll see that sign posted. Speed limit is 75. So what does that mean? So let's set up an inequality using S for our speed, the car speed. Let's kind of look at this phrase right here. 75 mile an hour speed limit means that you can go no faster, and that's the key phrase right there. No faster. What does that mean, no faster? That means 75 is the limit. You could go 74. You could go 73. You could go 70. You can go 60. You probably don't want to go too slow. There's actually a minimum speed limit as well, but I'm not going to get into that. Yeah, that no faster basically means that you can go less than or equal to 75 miles per hour. Okay, so let's put this all into a phrase. S is your car speed, is going to be less than or equal to 75 miles per hour. That is how that is done. Okay, our next real life example here is a height requirement for a carnival ride, or any kind of ride. This came to my mind when I was thinking of what could I use for an inequality where we look at, height. And let's look at this right here. Here's a sign. Again, I pulled this off of Google Images, but what we have is, in order to ride the tilt-a-hurl at the carnival, you must be at least, and there's the key phrase, at least 52 inches tall. So there's your chart right there, and there's your little, and of course you guys probably cheated, stand on your tippy toes, but yeah, you gotta be 52 inches tall. That's 4 feet 4 inches. Okay, so let's figure out how to do this. So at least, what does at least mean? At least means greater than or equal. So you have to be 52 inches tall, you have to be 53 inches tall, you have 4, you have to be 55, but at the very least you have to be 52. So now what we're going to do is we're going to use h. So h, your height, is going to be greater than or equal to 2 inches. And there's your inequality. Now another thing that you need to be able to do with inequalities is graph your solution. So you're going to have to solve these, which we haven't really done in this lesson, which you will in the future. You're going to solve these, and you have to graph them. You have to chart them, put them on a number line. Okay, so what I have here is a really simple inequality, and what we have is we have x is greater than or equal to, we have x is greater than 11. So in order to graph this, let me just kind of show you real quick how to do this, and then I'll talk about why things are the way they are after this. But what I'm going to do is I'm going to put an open point at 11, and that's going to indicate that's where I'm starting, and then I'm going to shade my number line, make it a little bit thicker than it was already, shade my number line to the right, which indicates greater than. This, it looks like an equation, but it's an inequality. What this is basically saying is that x is greater than 11. Okay, so can x be 12? Yeah. And if I check that, 12 is greater than 11. Can it be 15? Yeah. 15 is greater than 11. This line goes forever in that direction. Assuming that 100 is also going to be shaded, if we made it long enough, 100 is greater than 11. So this shaded region right here represents x. That's what x represents. You have to understand that when you're solving an inequality, it's different than an equation. Equations have one answer, one solution. Inequalities can have many solutions. Almost an infinite number of solutions. Say that. Almost an infinite number of solutions. But that is what x represents. X represents 12. X represents 13. It represents decimals, 14.5. It represents mixed numbers, 15.5. It represents an infinite number of possible solutions. So that x could be a lot of things. There's also a lot of things that x cannot be. X cannot be 7. X cannot be 8. And notice we do not have that part highlighted. Now, in my next slide, I'm going to show you why we used an open point and why we shaded the way we did. So the question that you are probably asking yourself is, how do you know whether to use an open or closed point? So you're going to use an open point on your number line when the sign is one of these. If it's less than or greater than, it's going to be an open point. You are going to fill in your points. You're going to fill them in if the sign is less than or equal to, or greater than or equal to. So it has a little line on it right there, and then you fill it in. Okay, and the filling in part of that point means that you're saying that it's equal. When you don't fill it in, you're saying that it's not equal. We're just saying it's a good starting point. Looks kind of confusing, but really simple rules there. So open, if you're using these symbols. Closed, fill in the dot if you're using less than or equal to, or greater than or equal. Let's do some practice problems. Okay, so right here we have x is less than 4. Okay, so our sign is less than, so that means we're going to use an open point, and we're saying that x is less than 4. So I'm going to shade the region that's less than 4. So everything less than 4 is to the left. And there you have it. So x is 0. 0 is less than 4. X can be a lot of things. X is 3. X is 3. X is 2. 1. It's a lot of different numbers. It can be a lot of different things. Kind of recap what we just did. We used an open point because it was just a plain standard inequality sign. It was just less than. If it was greater than, we would also use an open point. And then what does this represent right here? That represents x. X has many, many, many solutions. Okay, our next example right here, our next example here, just never mind this got kind of moved over, so I had to edit a little bit on the spot. But what we have is x is less than or equal to -3. Alright, now I have my number line already labeled. When you guys make your number lines, sometimes the number lines are not going to be made for you. Make sure, give yourself some room to work. And it's okay if you don't put 100 points on it. You don't have to do it the way exactly the way I did it. Okay, so now back to the inequality. We have the sign less than or equal to. And that tells us, since there's an equal to, that's going to be a closed point. So we're going to fill it in. when we graph it. Okay, so I'm going to find -3 on the number line, which is pretty simple. There it is. That's an open point, but this is closed, so I'm going to fill it in. Now make sure it's obvious that you're filling it in. Some people kind of partially do it and they say, oh, I filled it in. Make sure it's clearly filled in. Okay, not just half filled in. So you can get away with saying it's either one. All right, and then this says it's less than or equal to -3. So less than is to the left. And there you have it. There's your answer. The shaded portion represents x, and so does the closed point. The closed point could also be x. If I write the inequality, -3 is less than or equal to -3, that's a true statement. That's absolutely true. There's nothing wrong with that. -3 is equal to -3. So we have that or equal part. Next example right here. X is greater than or equal to -1. Since we have this symbol, what are we going to use? We're going to use an open or a closed point. It's going to be closed. There you have it. And then this symbol represents greater than or equal to, and that means I'm going to shade to the right. Greater than means numbers greater than -1. So this represents x. And that's all you have to do to graph it. It's a very simple thing to graph these. It is very simple, however, to mix it up a little bit. So make sure that you have these figured out the right way. Now, in my last example right here, I want to just show you that sometimes you're going to see inequalities written like this, where it's kind of backwards. And one thing that you might be told by future math teachers, I don't know, Mr. Gasson's going to stress this, but I would stress this as well, and it's that you want your x, or whatever letter is used, you want that to be in front. You want that to be on the left. And then you want your non-x, your non-letter, non-variable to be on the right, your constant. And if you are going to do that, you want to flip it around. And it's not just a matter of just taking this x and moving it here and taking this -14 and bringing it over there. We have to do another thing too. We have to flip the inequality sign around. Okay, so what you're going to do here is you're going to write it so that the x is first, the -14 is last, and our sign flipped completely around. Our sign was less than or equal to, and now it's greater than or equal to. So now we have x is greater than or equal to -14, and I'm just going to do this. This should be pretty easy for you by now. So you're going to make a close point there, and then we're going to fill it in to the right. Now, just to make sure everyone is understanding this, let's just kind of talk about this again. This represents x. All that shaded region, including the closed point, represents what x could be. X is a lot of different numbers. -10 is one of those numbers. So if I were to put that in, let me go back to the original equation. The original equation was -14 is less than or equal to x. If I put a -10 into right here, that should still be a true statement. A -14, is that less than or equal to -10? And that is less than. -14, I know it doesn't seem like it's less than -10, but -14 is smaller than -10. Think about temperature. -14 degrees would be definitely colder than -10 degrees. Still be really cold either way, but -14 is smaller. Okay, so that is a true statement by putting those numbers in there. And it would be a false statement if I put any of these numbers in there. So that does it, everybody. Hopefully you guys took good notes here. I covered a lot. It was very basic. We talked about the introduction, or we talked about the basics of inequalities, what the signs mean, how to graph them, how to write the word statement, how to write it. And we talked about what to do if it's a word problem and how to write that out as an inequality. And that pretty much covers it all. Everyone have a great night. I'll see you tomorrow.